So more live integration. People did not appreciate my handwriting or my use of a whiteboard, but you always got to give things a couple of goes, and I enjoyed it. So we're going to give it another go, and if it's still terrible, which the first one totally was, if it's still terrible, then we'll go back to the old-fashioned way, and that'll be fun too because I enjoyed doing that in the first place anyway. So let's find an integral. 581 is the integral that we're going to do. We all know the rules. I find a random number or using Google, and then we find the integral that relates to that number. We go to 581, which is all the way down here somewhere. And once we found it, we do the integration, and that's the entire system. Sorry for that, picking up a pen. 581 is x to the 5 e to the x cubed. Now that looks pretty cool straight away, because integrals that look cool are the ones that you don't know how to do just by looking at them, and I do not know how to do this. X to the 5 e to the x cubed looks very cool, dx. Instinctively, what I might try and do is break this up into something like a third x cubed times 3x squared e to the x cubed. And now the reason I'm doing that is because now this object here is I can just integrate. So now maybe I can do integral by parts. So leave this one alone to get a third x cubed, integrate the other one just to get e to the x cubed. And then we're going to take away the integral of, differentiate that one I'm pointing at here is, because you can't see me pointing, of course, is x squared. And then, of course, we still have the integral of this one here. And now this ends up going quite well. We managed to find the strategy right away, which is nice. Sorry, can't move this properly. Why is it not moving for me? There we are. It's moving finally. And we'll have, obviously, this integrates to, what even does that integrate to? A third e to the x cubed, I guess. And then, obviously, minus this thing here. And I think that's all that she wrote on that question. So yeah, hopefully that was good. Let's go back to our random number generator. And we'll have 184 this time. So we'll go back to the questions and we'll try as quickly as we can to find 184. Ooh, actually banged it out there. 2 sine 2x times cos of x squared. Now that seems like quite a cool one. Obviously we're thinking immediately of, so 2 sine 2x times cos of squared x dx. Now obviously we're thinking something to do with double angles here. Because 2 sine 2x, all of that, because sine 2x is 2 cos x sine x, is that not 4 sine x cos x? But then one of the cos x's can be donated to this cos x, and now this looks lovely because now we can just use the fact that this is f of dashed of x here sitting next to f of x. So this must be cos, and the 4 is even nice as well because it is where that 4 comes from there. I think we need a minus because cos differentiates to minus sine. And that is all that we need for that question there. So I'll get rid of this, move it out of the way, ready for our next integral. I'll probably aim to do 5, I don't know, just see how long it takes. That would be the rough aim per thing. 139, they give me another low one. So sorry, there's a lot of car beeping horns outside. That doesn't usually happen around here. 139 is x cubed into log of x squared plus 1 all in brackets. So this also seems like quite a cool one. So we've got x cubed into log of x squared plus 1 in brackets like this. I'm actually going to double check that because I'm concerned, if I just flick back to the other screen, I'm concerned that I didn't remember that properly. What is it? X cubed. I didn't remember it properly. It's x squared into a cubed. Cool, glad I checked that. So that's x squared here into x cubed over here. Just going to move this out of the way. Sorry for that. Sorry for that noise. I was just being kind of annoying in the way. Okay, so we've got this here. Is this straightforward? Is this not straightforward? That is the question. So obviously x cubed differentiates something of the form x squared, but that doesn't really matter when it's in a log, does it? Unless we can maybe make a substitution like u equals x cubed. And the reason that might work is because when we differentiate this for 3x squared dx, and we divide this to put it over there and then shove the dx into there, the squares will cancel. So that seems like quite a nice idea. So let's say this is the same as log of u plus 1 in brackets of du, and then of course we'd also have a 3 down here, of course, from this 3. So this would be a 1/3, and then everything else cancels. But of course, now log of u plus 1 isn't a trivial integral but you might know what it integrates to. Log of x integrates to x log x minus x. So I think I can just say that's u plus 1 brackets of log of u plus 1 minus u plus 1. And of course, there's a big 1/3 outside the whole thing. Just because that's a linear transformation, I think I'm just allowed to say that, and that'll be fine. Cool. So that's that one done as well. That's 3 down. I hope that was right as well. 336. People in the comments will, blissfully enjoy telling me that I'm not right about things. So I'll just leave that to you. Now, this is an interesting one because it's all about polynomials, which integrals that I don't usually like very much. Now, I've already forgotten what that actually said, which is going to be problematic. It's not an easy one to remember. I think it was on the top x squared plus 2x plus 2. I tried to remember the top alone, but I probably stuffed it up anyway. And on the bottom, it was a minus, and then you just swap the minuses over. Cool, that's easy to remember. So this is a minus, and then you have x squared minus 2x plus 2 down there. Now, what on earth do you do here is the question. Bottom side doesn't factorize. It could, I guess, be split up. I guess we could also try and replicate the denominator in the numerator. So, for example, if we wrote plus 2x as minus 2x plus 4x, we could then write this minus 2 as plus 2 minus 4. And then we could say that the integral is x squared minus 2x plus 2 over that same thing. This d2 means the same thing. Plus 4x minus 4 over, this same stuff over here, like so. Oh, and that's looking very nice, right? Because this whole thing, of course, something divided by itself is 1. So I think we found the right strategy here. This is the integral of 1 plus. Now, what's going on over here on this side? Well, I think this is the same as 2 lots of 2 minus 2. Or 2x minus 2, of course. And the reason that's, I should probably put a dx over here. The reason that's helpful is because I think that differentiates to 2x minus 2. So I think that this is going to be the integral. I think that it's going to integrate. So I just write that down there again. I think it's going to integrate to x plus 2 lots of log of x squared minus 2x plus 2. I might be wrong about that. That's the kind of thing where it's very easy to make a mistake when you're not really concentrating massively on what's going on. We've got one more to do, which is 136. I said I would do 5. If I want to, I might do another one. So this one, 1 over 2 plus root x dx, looks okay initially. I do enjoy making the substitution, so it's 1 over 2 plus root x, I believe. I'm going to double check that one as well. Sorry, I know this is wasting time. Skip forward in the video if you obviously don't want to see me check this 2 plus root. I was right. Okay. Okay, so we're obviously going to think about u equals x to the power half. Now this might work, it might not, I'm not sure. Differentiate both sides and we get a half x to the minus a half dx, which I guess we could then say is 2x the half du equals dx, which is 2u. So this becomes integral of 1 over 2 plus u times 2u du. Okay, well that surely isn't that bad to do. Bring out the 2, integral of u over 2 plus u. We could make a substitution here, and I think that's probably the way to go. We probably should have just substituted in the first bit the 2 plus as well, because essentially this is what I'm going to do here, isn't it? So we're going to say m equals 2 plus u. Now that's a linear transformation, so I don't need to worry about the du's or dm's. They're just going to stay the same. U is m minus 2, so it ends up being m minus 2 over m, integral of times 2 over here, I think still. And then, yeah, this is fine, because I guess we can split this out there. Integral of m over m, well, that's just 1 integral to m, and 2 over m integrates to minus 2 log m. And then, of course, we've got a 2 out here, I guess, and then we have to put this substitution back in. So it's 2 plus u minus log, 2 logs of 2 plus u, but then also put the u in as x to the power half, and then I think we're done. Only just because we've only just crossed the 10-minute barrier. Let's just do a bonus one. Let's just do a bonus one. Of course, now that I say that we're going to do a bonus one, this bonus one is going to take like 10 minutes. 4, 2, 1, and I'll be really frustrated that I did a bonus one. But let's at least try it. If I can't do it, of course, then we'll just say, well, this one is up to you. That was the whole plan all along. Sorry, I don't know why I'm scrolling down like that. 4, 2, 1 is all the way down here. 4, 2, 1 is there. Oh, this is an interesting one. 4 over x squared minus 4 or to the power 3 over 2. So it's 4 over integral of 4 over x to the power 4. Was it a minus 1 here, or to the 3 over 2 dx? I think that was it. Hang on. Let me just double check again. X squared minus 4. X squared minus 4. Sorry, I went for x4 minus 1. X squared minus 4. Okay, and now the moment I'm saying x squared minus 4, I'm thinking of sine squared plus cos squared equals 1. Because if you allowed x to equal like 2 sine u, then that would square to 4 sine squared u, and then you could say that's 4 sine squared u minus 1 is, but it's a, should I go with, because it's not, so you would have a minus. The other option, so if you do that, you'd have a minus, it would end up equaling like minus cos squared, which is probably fine. The other option would be to go with the tan sec relationship. Tan squared plus 1 is sec squared. So tan, no, that doesn't work either, does it? I'm looking for something minus the number. Yeah, sec squared minus 1 is tan. That's right, sec squared minus 1 is tan. So we could be fancy here. I'm pretty sure what I just wrote down there would have absolutely worked. But let's be fancy. Let's write it as 2 sec u. Because then we definitely, let's just do it this way. I think this would be nice. It'll be fun anyway. Differentiate to get 2 sec u tan u du. And now x squared is 4 sec squared u. So factorize out the 4, which roots and then cubes to an 8. So we'd have 1 over 8 out here, or 1 over 2 if we cancel out this 4 with the 8 that we get when we do that. And then we'd have a tan squared in the bracket, which would then be raised to the power 3 over 2. So that would be a tan cubed down here, I think. And then, of course, we have all of this object here. Now that 2 will cancel that half, which is nice. And we'll end up with a sec tan du. So sec tan du. There should also be some u's in there, but I can't be bothered. So this is the same as sec u over tan squared u du. Now, the minute we look at secs and tans, we're thinking about the fact that they differentiate sort of vaguely to each other, aren't we? But unfortunately, I don't have a sec squared. Tan differentiates sec squared. So if I had a sec squared, that would be beautiful. But I don't. And I don't think I've made a mistake, although I almost certainly have. So we're going to have to maybe think of something a little bit more intelligent here. Tan squared, we could maybe write that as sine squared over cos squared. Sec squared is, of course, 1 over cos squared. So is there enough cancelling here to make this work and just kind of get me sines and coses that work well together? We'll have a sine squared on the bottom, sorry, because that's where the tan squared is. This cos squared, which is underneath the whole fraction, bounces to the top and cancels with because sec is 1 over cos, that cancels a little bit with that. So we now have cos over sine squared, which is the same thing as cos times sine to the minus 2. And I think this is a situation that why are those 2 lines there and why aren't they going away? Anyway, so let's just move the board and make sure we have this written down nice and clearly. We have integral of cos u sine u to the minus 2 du. And now the reason that's nice is because this just integrates to sine u to the minus 1 with a minus in front because sine differentiates it straight to cos. And we're pretty much done. And then we can put the substitution back. The substitution was 2 sec u. So this would be a nice comment. What's the nicest way to put that substitution back? You could just say it's arc sec of a half x is equal to u, and then say the answer is sine to arc sec. Is there a nicer way? Answers on a postcard, please, of writing that. And thanks for watching. I'll see you next time.